Welcome to WebRTC Live. In WebRTC Live, we cover the latest technical topics and business use cases for WebRTC and live video. As always, this episode is brought to you by WebRTC.Ventures, leading integrators of WebRTC video into your custom application.
Welcome back to WebRTC Live. I'm your host, Arin Sime, founder and CEO at WebRTC.Ventures. WebRTC.Ventures is a custom design and development agency specializing in live video applications, and we're here to help you take your video application live. You can learn more about us at WebRTC.Ventures. Today, I'm joined by Justin Williams, a senior engineer on our team at WebRTC.Ventures, who will be talking with us about automated testing and WebRTC applications. Justin joined our team in August of 2020 and already brought with him deep expertise and experience integrating WebRTC with the latest tools and frameworks used in the industry today. In addition to his excellent development work with us, Justin's a valuable member of our growing testing team, where he's helping to define the architecture of how we test video apps at WebRTC.Ventures. It's a really interesting topic. As I've said before in some other episodes of WebRTC Live, one of the interesting things that we've observed from our perspective in the industry is how a few years ago, so many of our clients were startups really just exploring ideas around live video applications, and now much more mature client base and people interested in scaling applications. And obviously, due to the pandemic, people are using WebRTC so much more than a couple years ago. And so that means that things around testing and scaling and are so much more important than they were a few years ago for a lot of our clients and in our work. And so this is a really interesting topic for us. Justin's going to share with us more about it. He's joining us today from Toronto, Canada, and also studied computer engineering at the University of Waterloo there as well. So Justin, thanks so much for joining us today.
Thanks for having me, Arin. Glad to be here.
All right, so I'll go ahead and turn the screen over to you, and Justin will share with us more about automated testing. You are welcome to put your questions into the chat in the tool at any time, and we'll make sure that they get addressed. All right, Justin, the floor is yours.
Thank you. Hi, so I'm Justin Williams, engineer at WebRTC.Ventures, and like Arin said, today I'm going to be discussing automated testing, WebRTC video applications. So I'll start by talking about what is automated testing, and I'll provide a basic overview of the types of tests. And I think it's very important to have the idea that all applications should have tests, as maintaining quality and performance is very difficult to do as your application complexity increases and your constraints change over the course of the application. So I'll then talk about how to get the most out of automated testing, and then we'll also focus a little bit on specifically testing WebRTC functionality in your applications. So what is automated testing? So automated testing is using software to validate the behavior of our applications. Automated tests ensure that as the code changes, its behavior continues to be as expected. And there are various types of automated tests. So at a high level, they are unit tests. So unit tests are low-level tests. They test small units of code, and that's in isolation from the rest of the application. So these ensure that the code, as we add code or change our code, the building blocks continue to work as expected. And unit tests should be written whenever there's new code added, and they should be updated when the code is changed. Unit tests are kind of more for the developer to validate their logical units of code. And just because you have your unit test passing doesn't necessarily mean there's no bugs in your whole application. Integration tests are sort of high-level tests that kind of generally test the application on a whole, so the application working with its various components. And these tests can be written to simulate real user actions and validate business logic and feature functionality. So integration tests tend to be quite verbose, and these tests may be hosted in like a separate repository to the application code. And finally, load testing. So load testing can be integration tests, but they run at a very high scale. And these are kind of meant to stress the infrastructure of your application so that you can sort of benchmark it. And they provide insights into things like how many concurrent users can use your application or a certain feature of the application. And they can also expose bottlenecks or performance constraints of your application. So a little bit deeper into unit tests. Like I said, they maintain the behavior of the code itself, specifically the individual classes or units of code that are considered to be the building blocks of your application. So, you want to have the mentality that good unit tests, they're small, they're very easy to maintain, and they test only one thing. And one thing to note as well is it's not always possible to get 100% coverage with unit tests. So there may be a few instances where you have code that's not really testable, but unit tests should have little to no logic in it. Untestable code should have little to no logic in it. And you can use programming practices to separate out the logic as much as possible from this untestable code. And then you can unit test that logic. Ideally, unit tests should run very fast. Any external services, such as databases or like a remote API, those should be mocked out. And unit tests should be run very regularly by the developer. A common practice is to have the developer run the unit tests on their local environment before pushing the code to even be reviewed. So integration tests, they generally execute, like I said, against the whole application or at least a subset of the components working together. Integration tests, they can use real environments. For example, you spin up Google Chrome to launch and run your application. And they can also be written from the context of how a feature is described. So for example, you can have an integration test to test the login flow of your application. So it may run Google Chrome, bring up UI, and it could do a quick validation to make sure the UI loads as expected. Maybe your application has some inputs which requires validation. So your test can verify that that validation does take place. And then maybe the test continues along and your application makes a post to the server. So that'll be a real post. So you have now your application and the server working together in the test. And then maybe the server even authenticates the user with the third party. And the test can then determine whether or not the client was redirected successfully and the login was complete. So integration tests, they should replace repetitive manual tests. So for example, smoke tests or regression tests. One thing is if your application if you have manual test suites with your application that maybe you use to do smoke tests or regression testing every time you have a release going out, you'll have the automated tests sort of replace these. So you can go one at a time to replace manual tests to integrate automated tests into your application. And then what you can do from there is you can have manual testing, and that can be left for more exploratory test cases or maybe even test cases that are really hard to automate. And then load testing. So load testing can be used to benchmark the performance of the application and its infrastructure. So before releasing an application into production, it is important to know how much load or concurrent users your application can handle. So it's generally pretty difficult to exactly mimic production traffic before you release your application. But load testing insight is still very valuable to know whether or not the infrastructure can support your production load. Maybe your infrastructure has auto scaling, so load testing again can then be used to ensure that scaling occurs as is necessary. And for WebRTC specifically, you might see service deterioration, which can cause low quality calls or calls failing to set up altogether when your infrastructure is under high load. So it's good to know or get that benchmark pretty early, especially before you release to production. Another thing too is maybe some media servers might have some business logic in there. For example, maybe it can allow or not allow a call for certain users. And this sort of thing can be an example of a bottleneck in your infrastructure. So load testing can help you identify something like this. A couple examples are JMeter, which is a popular load testing tool, and I think generally works with Selenium tests. And then Kite is a library providing an engine for testing WebRTC specifically in browsers or native mobile applications. So why do automated testing? So application complexity makes writing new code difficult. At the early stages of development, adding new features is pretty straightforward, but for a complex and a mature application, adding new features generally comes with a large amount of testing to ensure that no previous functionality has been broken. As undetected bugs, they can be very expensive to fix if they exist for a long time. So having to rely on manual tests every time a feature is added can be kind of time consuming and expensive. So spending the upfront time into getting a solid automated test suite can go a really long way in terms of speeding up and even shoring up your development cycle. Automated tests allow for like frequent test runs to provide developers feedback on their code before it goes into production. And by being able to run tests so easily and so quickly, this pretty much lets us catch bugs really early on and prevents them from making it into production. So here's a high-level overview of a continuous integration workflow. So it's a very high level and abstract. And what you can kind of envision here is that you have your developer working on their local dev environment. Unit tests, they can run locally, hopefully very regularly. And say they have code, they're ready to push it up to the version control. The version control system, whatever is being used, whether it's GitLab or something else, that can integrate with your CI server, and it can run your tests. Maybe it's going to run whatever tests you have, hopefully most of the time unit tests as well as your integration tests, and then it'll report back to your version control system, and it can be up to the developer to then analyze the report and decide sort of what to do next. So the best way, it's pretty much the best way to get value from integration tests, because what you really want to do is you want to be running them with every code change that you do. So continuous integration can be set up to detect when a developer has already proposed a new change, kind of like we saw there. And ideally, like I said, run both integration tests and unit tests before the code's allowed to merge into the main branch. CI servers, like I said, can post test results back to the version control system, and lets you catch bugs sort of a lot earlier there. Undetected bugs, like I said, they can cause a lot of issues, and the longer they exist, the risk of complexity gets bigger while new code changes are added, and just going to be really hard to fix. One metric that we do sort of look at and keep in mind with continuous integration and testing in general is the metric of test coverage. So this metric is used to determine how much of the application's features are tested. So high test coverage leads to more confidence in your integration tests. And you can also have the continuous integration server keep track of the coverage over time. And that can show what areas of the application code base are maybe lacking in test coverage. There's another look at the CI workflow. So one kind of cool thing to note here is that the version control system can work with the continuous integration server. And one thing that you really want to sort of have is a nice reporting structure so you can make use out of the results of your test. And there's a few different services that provide various reporting sort of formats or like ways of doing it. For example, the Allure reporter that can generate reports as static HTML files, and your CI server can provide a link to these files in the version control system so the developer can just click it, or maybe your version control system can parse those reports and show it nicely. So sort of the next step from continuous integration is continuous deployment. And while continuous deployment is very hard to achieve, it's a pretty good practice to have this sort of be your high level goal where you want to get to, kind of like the holy grail of your CI workflow. And we'll kind of talk about why in the next slide. So what is continuous deployment? So continuous deployment uses the reporting from the CI servers with an automated deployment process to check that code submitted by developers is ready to be deployed to production. So this does require that your automated test foundation is really solid, and you need high test coverage to be sure that newly added code does not cause issues. But with that said, it does lead to very quick development cycles and faster iteration on features and faster bug fixes, and generally a pretty easy development experience. So now we're going to talk about some of the difficulties with automated testing. So there are a lot of nice benefits with having it, but there are some difficulties. So the upfront work sort of required to provision continuous integration servers and write the foundation for the automated tests can be a lot of work and very time consuming. If the application requires things like authentication or some sort of third-party service integration, this has to be set up in the automated test infrastructure as well. Another thing to note is some tests may allocate resources on the infrastructure while they run, and that can change the state of the infrastructure and your application. So if you're running a lot of tests, kind of one after the other, you might have some tests that don't expect this change in the state, and that can make them randomly fail. This kind of thing is known as bleeding tests, and it's quite difficult to resolve because you might run the test on its own, just by itself, just to try to reproduce what happened, and its failure doesn't happen. It might only happen if it runs with all of those other tests kind of happening before it. So that's why it's really important to have a solid continuous integration infrastructure, and following best practices is essentially required to reach this ultimate goal of continuous deployment. For example, you might have your testing infrastructure include a library which can allocate these resources for a test. The library can do things like ensure that when the test completes, the resources are released and the state is back to where it was in the beginning or at the start of that test. An example of this library maybe is that it's a user creation service, which will create the users, allocate the resources as necessary, and release those resources when the test is complete. Having a continuous integration workflow set up as early as possible in your project lifecycle kind of makes everything easier as well. It's a lot easier to maintain the continuous integration setup rather than try to catch up to the application that may be already deployed to infrastructure, to production, sorry. So difficulties of testing WebRTC video applications kind of specifically. So testing WebRTC applications provides new areas of difficulty compared to testing maybe a vanilla HTML application, maybe like a blog website or something like that. WebRTC applications tend to have a more complex application state, and this complex application state can make writing tests difficult. It also makes tests more prone to failures with code changes made to the application. So as we've seen on previous episode of WebRTC Live, debugging WebRTC applications, there can be many reasons as to why WebRTC can fail in an application. So for one thing, your network configuration for the test environment can cause issues. Strict firewall rules can do things like block UDP, block inbound signals, throttle your connections, things like that. And if maybe you want to use a third-party service to run all of your automated tests, this third-party service would then have to be vetted for WebRTC operability. Sometimes it just won't work with WebRTC. Maybe you have a turn server, but sometimes, depending on what the firewall rules are like, that can make WebRTC not work altogether. Another thing, too, is browser inputs can be difficult to configure, especially if you want to have fine control over what is being sent as the browser input. Another difficulty is determining call quality. That can be pretty difficult within an automated test environment. And one last thing is that as browsers are updated, some APIs may change, and this can cause failures in the application. So you kind of want to make sure that you're testing various browsers and various browsers versions. But hopefully now with the standardization of WebRTC 1.0, this can be a rare occurrence. And I think in the past little while, it has been a pretty rare occurrence. And then verifying these WebRTC tests. So how can we verify WebRTC integration is working as we expect? This can be a very difficult thing to do to verify that a call is connected. But one thing, it is important to focus on the application logic or the application integration with WebRTC specifically when writing these tests. So for example, you might have a WebRTC application display the state of a call somewhere in the UI. So you can use this state to determine whether or not a call has been connected. This kind of test can effectively prove that the application has successfully integrated with the calling libraries and that it was able to set up a call. For applications supporting video calling, you can have a fake video stream that's sent to the call. Then the test can take a screenshot when the call is connected. Then you can have the screenshot compared to a screenshot from a previous test run that is known to work. And it can do a diff on the images. And this diff can then be used to ensure that the video was sent as expected. Another thing too, this one is really useful, is the RTC pair connection get stats API. You can use this to get the call stats for the WebRTC call, and we can do things like verify if packets were sent and received, and verify that a call was connected. Another thing too is third-party WebRTC monitoring and testing services can be used to help verify that WebRTC calls connect as well. We'll touch on that a little bit later. And one thing to consider as well is if you have integrated with a CPaaS in your application, that might change a little bit the direction of your tests, whether you're going to be focusing more on just like the application functionality and the business logic there, or if you really need to focus on your actual WebRTC integration and infrastructure and how that works. So right now I will show a quick demo of an example test that we have set up. So the test is going to be run from my command line, and it's using WebDriver.io, and we'll get started with that. The way that this test works is it's going to spin up 2 instances of Chrome, and it's going to perform a call between each of them, and it's going to be using a fake video stream to integrate with the camera and the audio. So one thing to note is that this, like I said kind of earlier, spinning up actual Chrome, and it is using the real application. And this is real time too. This is a recording, but this was real time, so you actually had 2 browsers talking to each other. And as we can see here, this is using just the straight up fake devices flag given to Chrome. So the video and the audio is done by the Chrome browser. But you can see here that they were connected, and if I pause it, you see there's like a little bit of a delay on the right side versus the bottom left side of the video. And I'll just show, so at this point now I've kind of held the test, and I wanted to show that this is the actual browser and we can interface with it. So here I'm going to click some buttons, so I'm muting it, disabling the camera. So from here what we can do is kind of those things I already spoke about from before. We can interface with the GetStats API and do a little bit further detection on how well the integration with WebRTC is. Right now, the way that these tests work is they look at the UI, and when the state change happens in the UI, those are the way that the tests are performing validation on the test run. So testing call quality. So as I kind of spoke about, if the application does use a CPaaS, this might not be the best use of your time to focus solely on the quality. You want to focus a little bit more on the application logic itself, as if you're paying for the CPaaS service, that's kind of the thing. One of the things you kind of get out of it is that you can rely on the CPaaS and its quality and its behavior under load as well. If the application uses infrastructure, though, that's running maybe open source on servers that you manage, then testing quality is definitely important. The infrastructure should be load tested, and quality is monitored, and have quality monitored to determine at which point you might have deterioration start to occur. As I've noted, the GetStats API can be used to check the stats of a WebRTC call. And the stats included with that API can give you things like the number of packets sent and received, packet loss ratio, and the latency. And then what you can do from there is you can take those values and you can calculate an EMOS or a mean opinion score from those values. And a MOS is just a rating on a scale of 1 to 5, where 5 is an excellent call quality and 1 is an extremely poor call. So you can have your test set up to calculate the MOS, and maybe something like a 3 or a 4 can be used as a threshold to fail or pass your test. Automated tests can also record the call. The recording can then be saved for manual review. Another approach would be to run the call audio against a PESC algorithm. This can determine the quality of the call and return a MOS as well. And I've provided a quick link to this. It's a kind of a nice tool. It's kind of a cool thing to use. However, you're not really going to get too much value from it, because with the GetStats API, you can actually focus a little bit more on what exactly is going wrong. Using something like PESC, might be better for black box testing where you don't really have too much control over the application itself. Another thing to have is really good logs. So WebRTC tests can fail for a variety of reasons. Whether it's in a testing environment or even your production environment, having logs on the client side specifically, you should always have logs on your server, but on the client side specifically, this can go a really, really long way into helping you debug your application. And in a testing environment, it's actually a little bit harder sometimes to debug some of these issues. So, having logs that maybe give you an idea of the state of the application at the beginning, throughout the call, and at the end of the call, that can help you diagnose issues a lot easier. And just want to touch a little bit more on using a testing and monitoring service. So TestRTC is a really awesome example of this. So kind of what it gives you is you have already provisioned test infrastructure, and that solves a lot of these issues that I kind of spoke about with automated testing. So having this pre-provisioned and maintained infrastructure allows for the developers to kind of just focus on the testing themselves, focus on the testing of the business logic of your application. And these type of services give you a lot of APIs and tools to help you validate your WebRTC integration as well. So load testing and call quality monitoring sort of comes for free with these services, sorry. Another thing too is there's always new ideas and new tools and services to be looked at and used with WebRTC applications, such as maybe a connectivity test and various methods of performing connectivity tests, specific to your application as well. So having a service provide these tools can also save a lot of time and effort with testing WebRTC applications. And that's it.
All right. Thank you so much, Justin. There's a ton of information there. Really appreciate it. We'll be putting that up on our blog at WebRTC.ventures too. And yeah, just a few questions for you. So I know that there's a lot of efficiency to be gained from automated testing for sure. And you've definitely shown that in this and a lot of different ways you can do automated testing. You mentioned there still is a role for manual testers though also. And so I just wanted to kind of follow up a little bit on that. And so, what sort of situations is manual testing either important in place of or complementary to automated testing in your perspective?
Yeah, manual testing for sure will always be very important. Sort of like I said, you ideally want to have your automated tests replace the more repetitive tests that you kind of do like as a smoke test. But for manual testing, you really want to be exploratory, test really very odd edge cases. An example is maybe you have a really strange microphone that doesn't seem to work all the time. Something like automated testing is going to be hard to reproduce something like that, but you can plug that into your computer and test it out there and see kind of how it goes.
Right. Yeah, definitely. I think totally agree. And I always think too with it's sort of like people talk sometimes about even machine learning or AI. It's as smart as we can build it to be to a degree. I mean, obviously those should be able to be smarter than us too. But in an automated test where we're writing the script, it's completely true that the script is only as good at testing as we program it to be, right? Which by definition means that it's only going to test things that we think of to tell it to test, right? And so there's still, that role for exploratory testing too.
Definitely.
I know you just had a big launch with a client you were working with, and without mentioning names or details of their application, I'm curious, what was the role of automated testing in that, and what sort of benefits did you see from that?
Yeah, for sure. So we didn't have any integration tests, although that is being worked on. What we did have, however, from inception of the project is unit tests, and unit tests are very valuable throughout the lifecycle of a project because the requirements for your application change, and certain of those changes can cause you to change a lot of the code and some of the building blocks. And what you want to do is when you're updating your application to fit those new requirements, you do want to make sure that you don't break any existing functionality, especially at that low level. if you're changing something at a very low level, the impacts of that can actually be really big. So you want to make sure that you have a solid unit testing infrastructure, and that definitely has gone a really long way.
Yeah, definitely. And I think it's an interesting point too, that these different types of automated testing that you do may come at different phases. So I think it was a really important point you made about setting up that infrastructure early, because definitely we know once a project reaches sort of legacy status, which is really the first time you deploy it to production, it's now a legacy application. And at that point, it gets a lot harder to justify going back in and doing some of the DevOps to create anything for a continuous integration environment, right? You don't want to wait too long to get started with that, for sure, as you said. But at the same time, if you have the foundation in place, you can add on more to it as you go too, right? And I was thinking also about around load testing, and when do you load test and when do you not, kind of during your presentation. And I think this is kind of applicable to some of the work you've done recently too, where automated testing and functional automated testing is definitely important. Maybe load testing isn't, right? Because it depends on how are you using WebRTC, right? If you're using WebRTC as the delivery method to millions of users, right? Or millions of users are directly on your WebRTC application, then obviously auto scaling and load testing become really important. In other cases, like some of the work I think that you've done recently, you're using WebRTC really for ingestion, but then displaying to users through more traditional broadcast techniques that, are already well tested, right? If we took a simplistic example of, let's use WebRTC to record this webinar, but then we're going to stream it out to YouTube. All of our users, our viewers, are on YouTube, right? We don't really have to scale that, right? So,
exactly.
Yeah, just kind of wanted to follow up that with you and see, what do you think about the, when you load test and when you don't, or how you go about that?
Yeah, for sure. I mean, it is really hard to know at the beginning of, or while developing application pre-production, what your production traffic is going to be like. And it is very dependent on the use case of your application. And are you using, already proven services and software to deploy and host your application? Maybe you have it running on AWS and you're using CloudFront, using those best practices there. You don't really need to write an automated test to load test that sort of infrastructure. But as you mentioned, yeah, if you're using WebRTC to host something at a very large scale, then definitely you're gonna want to load test that to determine when deterioration will start to occur.
Yeah, absolutely. And I like that service deterioration phrase that you used a lot, because I think it really emphasizes what's different about automated testing with WebRTC, because traditional automated testing is a lot simpler. You're testing if buttons appear or calculations work after a button is pressed, that type of thing. Something shows up in your shopping cart, right? It's more of a binary test. With video, we're talking about things that have a more qualitative nature to them and are harder to automate. And so we're not just testing, does the web page still load when there's a lot of users on it, but is the quality still okay? And so that phrase, service deterioration, I think is a really important one to think about.
Yeah, definitely.
So a couple questions from our viewers. Juanes, do you have any frameworks that you recommend for testing WebRTC and mobile targets, iOS or Android?
Yeah, for sure. Well, I definitely want to say the unit testing, you should definitely look at that. And for iOS and Android, iOS, you can use I can't remember what it's called. It's kind of within the iOS framework, Xcode unit tests infrastructure. And for Android, if your application's in Java, having unit tests in JUnit is actually a really good way to go, because while that might seem simple, you do want to be unit testing just your logical basic building blocks of your code. And JUnit is pretty bare bones, and it's going to test a lot of vanilla just Java, and that's the perfect setup for that. Now, with testing WebRTC specifically, it can be quite challenging to get enough test coverage with your unit tests. So you do want to definitely look at integration tests, and a tool like Appium, which is similar to Selenium, but for mobile applications, can definitely help you there.
Yeah, absolutely. I always think with mobile testing too around video, this is an interesting area to consider a combination of manual and automated in the sense of using automated tests, as in particular if you're talking about like scale and service deterioration load testing to run a load test on your whole system, web and mobile, but at the same time, in parallel to all that automated load testing is running, to do some manual qualitative testing on your mobile devices, because on mobile that may be where you see problems first, right? Because it generally have more constraint around resources and more likelihood to see connection problems, et cetera. So doing some manual testing on mobile devices in parallel to a load test running, I think is an interesting combination of those techniques to use as well. So, all right, another question. What are the two most important things to test in a WebRTC application first? This sounds like a quiz. I wonder if they already know the two answers here.
Yeah, for test. Let me think about that. Which two more important?
Yeah, what would you test first in a video application? You know, I guess putting aside, you've already done enough testing to get schedule an appointment, for example, right? The example you were using was a telehealth solution we built. So you've already done the automated testing to schedule a call with a doctor and to go open the call at that point. But now you're getting to the point where video is going to happen, right? Yep. The connection's being established, whatever. What would you test first about WebRTC specifically in that application?
Yeah, so definitely starting simple is probably the best way to go. You'd want to make sure that the integration does work as expected. So your automation tests can run and actually have the application integrate with the library you're using, making sure that no sort of errors occur there. And then you can do something like screenshot testing to verify that, even though there weren't any errors, it did actually connect to the video and it did stream the video across the two browsers.
Yeah. Okay. Excellent. Thank you. All right. We've got a couple other questions around maybe a little bit of a follow-up here or similar to Juan's question, but any other recommendations around doing load testing cross-platform?
So there are tools like Kite that I mentioned earlier. I kind of just briefly described it, but it's a library that provides a testing engine for WebRTC, and that allows you to have a lot of functionality in terms of where you're testing, and that will work for web applications and mobile applications.
Yeah. And any thoughts on testing with more complex network scenarios? So thinking about when you're trying to establish that WebRTC call here, I think Daniel's probably imagining in the question of what if I can't get ICE candidates? What if I can't establish the call? How do you do that sort of testing?
Yeah, and there can be a variety of different ways to approach that. I have done that before by actually running an automated test from my laptop. And I think with the Mac OS, you can actually change some settings to throttle the internet connection, maybe have a certain amount of packet loss in there. And there are a lot of tools. I can't think of any off the top of my head, but you want to look for tools that can maybe proxy your internet connection to the automated test and let you have control over that. So how does my application look with 15% packet loss? How does my application look with 80% packet loss? Maybe you can put a high jitter in there as well. So various things like that. There's tons of tools available for that, and that can go a long way. But it is very difficult to simulate real user setups. So yeah, that's actually a really good candidate for manual testing as well.
Yeah, manual testing or testing in sort of your local, like an office Wi-Fi type of scenario too, where you can configure some of those things through router-based applications so that you could set up, different network connections based on different speeds and then connect devices to that for the automated testing. But
yeah, for sure. And I've seen
complex scenario.
Yeah, and I've seen some really weird functionality with various VPNs as well. Talking about gathering ICE candidates and stuff like that. VPNs, it's good to test your local environment manually and test with VPN without a VPN, because a lot of people are working from home these days. So everybody's probably going to have a VPN for their home setup. Definitely really important to check that out.
Yeah, absolutely. All right. Well, Justin, thanks so much for your time, for the excellent presentation. Thank you, everyone watching, for your questions. We'll be posting this video to YouTube and our blog at WebRTC Ventures, as we always do. And I also want to mention briefly a couple of upcoming WebRTC Live episodes that we have. We're going to have a special double episode in April with the Cosmos software team. First on April 14th, Ryan Jesperson, streaming media engineer at Millicast, will be talking with us about building a new generation of interactive real-time streaming solutions with WebRTC. And I know there's going to be some really cool topics in that around real-time streaming with the Super Bowl, the NFL, as well as NASA's Perseverance rover landing. So I'm really looking forward to that one. And then on Wednesday, April 28th, we'll be talking about further evolutions in WebRTC with Dr. Alex from Cosmos Software and also founder of Millicast. And topics in that session will include the evolution of the WebRTC media pipeline, and AV1. So a couple of really interesting episodes coming up to join us. To learn more about those and to get details on when you can register for those, just follow us on Twitter at WebRTC.Ventures. Join our email list at WebRTC.Ventures. And we'll keep you informed about all the great episodes of WebRTC Live coming up. Justin, thanks again for your time today. Really appreciate it.
Thanks for having me. It was awesome.
Our pleasure. And thank you, everyone, for joining us today. Let's make it live.
Thanks for joining us for WebRTC Live. Visit our website at WebRTC.Ventures to learn more about our custom design and development services and to learn more about upcoming episodes of WebRTC Live.